This is the Catch-Up Network.
Discover how the Model Context Protocol, MCP, is revolutionizing AI by seamlessly connecting agents to databases and APIs, empowering them to utilize diverse data sources effortlessly. This open source standard is essential for developers looking to enhance AI capabilities and integration, embrace the future of AI system connectivity, and tool utilization with MCP's innovative approach.
If you're building AI agents, you probably heard about MCP, or Model Context Protocol. MCP is a new open source standard to connect your agents to data sources such as databases or APIs. MCP consists of multiple components. The most important ones are the host, the client, and the server. So let's break it down. At the very top, you would have your MCP host. Your MCP host will include an MCP client, and it could also include multiple clients. The MCP host could be an application such as a chat app. It could also be a code assistant in your IDE, and much more. The MCP host will connect to an MCP server and can actually connect to multiple MCP servers as well. It doesn't matter how many MCP servers you connect to your MCP host or client. The MCP host and servers will connect over each other through the MCP protocol. The MCP protocol is a transport layer in the middle. Whenever your MCP host or client needs a tool, it's going to connect to the MCP server. The MCP server will then connect to, for example, a database, and it doesn't matter if this is a relational database or a NoSQL database. It could also connect to APIs, and also the API standard doesn't really matter. Finally, it could also connect to data sources, such as a local file type or maybe code. This is especially useful when you're building something like a code assistant in your IDE. Let's look at an example of how to use MCP in practice. We still have the three components. We would have our MCP host and client. Of course, we also have a large language model. And then finally, we have our MCP servers. And these could be multiple MCP servers or just a single one. Let's assume our MCP client and host is a chat app. And you ask a question such as, what is the weather like in a certain location, or how many customers do I have? The MCP host will need to retrieve tools from the MCP server. The MCP server will then conclude and tell which tools are available. From the MCP host, you would then have to connect to the large language model and send over your question plus the available tools. If all is well, the LLM will reply and tell you which tools to use. Once the MCP host and client knows which tools to use, it knows which MCP servers to call. So when it calls the MCP server in order to get a tool result, the MCP server will be responsible for executing something that goes to a database, to an API, or a local piece of code. And of course, there could be subsequent calls to MCP servers. The MCP server will reply with a response, which you can send back to the LLM. And finally, you should be able to get your final answer based on the question that you asked in the chat application. If you are building agent, I would really advise you to look at MCP protocol. The MCP protocol is a new standard which will help you to connect your data sources via MCP server to any agent. Even though you might not be building agents, your client might be building agents. And if you enjoyed this video, make sure to like and subscribe.
The Model Context Protocol, MCP, represents a pivotal advancement in the integration of AI agents with data sources such as databases and APIs. At its core, MCP seeks to standardize the data access layer, enabling a seamless connection between disparate systems. The introduction of MCP as an open source standard acknowledges the need for a cohesive framework that supports flexible AI systems, particularly in applications requiring real-time data processing and dynamic interaction with complex data ecosystems. This is crucial given the growing reliance on AI for decision-making across sectors. The emphasis on components such as MCP hosts, clients, and servers reflects the architecture's modular nature, allowing for robust scalability. The comparison to existing standards such as RESTful APIs and GraphQL establishes MCP as a flexible alternative designed to engage with a variety of database architectures and protocols without the overhead of protocol-specific constraints. This adaptability positions MCP as a significant tool for developers aiming to enhance AI capabilities in an agile development environment. Moreover, the protocol's ability to interface effectively with large language models, LLMs, is particularly relevant as LLMs are increasingly employed to handle complex queries, thus necessitating efficient data retrieval mechanisms. The focus on practical applications, illustrated through scenarios like real-time weather inquiries or customer data analysis, highlights MCP's potential impact on improving business intelligence and operational efficiency. As AI agent frameworks evolve, integrating a comprehensive protocol like MCP could herald a shift towards more intelligent, intuitive, and responsive AI-driven applications.